Louise and Andrea were tossing a fair coin and investigating run size. They had defined run size as the number of times the toss resulted in the same outcome, either heads or tails, before changing. So, examples, 5 tosses resulting in HHHTT represents a run size of 3, that's the 3 heads, followed by a run size of 2, which is the 2 tails. Then we've got 6 tosses resulting in tail, 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 head, head, tail, is a run size of 3, followed by a run size of 2, then a run size of 1. We want to write an example in which 10 coins are tossed and there is a run size of 3, followed by a run size of 5, then a run size of 2. So I'm going to start with 3 heads. Then I want a run size of 5, so it needs to change to tails for 5. And then a run size of 2, so we need to change back to heads. The result from 20 tosses of a coin are shown below. How many run sizes of 3 are there? Well, it looks like we start off with a 3 here with these heads. Then we just have 2 tails. Then we have 2 heads, and then I've got 3 tails, so that's another run of 3. Then we've got 3 heads, so that's another one. Then we've got a single tail, a single head, a single tail, 2 heads and 2 tails. So it looks like there's 3. Louise and Andrea had tossed a fair coin 100 times in their investigation and recorded the number of times the run size occurred. The results are given in the table below. What was the largest run size? The largest run size will be the largest value here that has a non-zero frequency, so that's going to be 6, and that occurred twice. In the process of calculating the mean size of a run, Louise divided by 100, while Andrea divided by 44. Who was correct? Well, I'm going to say it's Andrea, and then I'm going to explain. If we total these frequencies, we get 44. We're calculating the average run size, and therefore we should divide by the number of runs, not the number of tosses. So you need to write that here when you explain. Using the information in Part C, determine the mean run size, the median run size, and the standard deviation of the run size. And the fact standard deviation is mentioned here tells me that what I should do is go to the calculator. And I'm just going to clear out anything that I have in there. And then in list 1, we'll put the actual run sizes. So 1, 2, 3, 4, 5, 6. Always check your data, make sure you put the right things in. Then we'll go into list 2 and we'll put it in the frequencies. So that's 18. Then 9, and then 9 again. And 5, 1, 2. Again, make sure you've transferred the data into here correctly. And then we're going for calc and 1 variable. The actual data values, the run sizes, are in the X list, and the frequencies were in list 2. Click OK, and we can see now that the mean is 2.27. Let's get the calculator back, and the median is 2, and the standard deviation, the one we use in this course, is the sigma, so that's 1.39. Louise and Andrea wanted to collect more data and decided it would be quicker to run a simulation using a spreadsheet on their calculators. What calculator function would be useful to generate numbers to represent the outcomes of the coin toss? So if we look at a spreadsheet here, what we want to do is generate random numbers. So if we put in here, let's just get the keyboard, and what we want is that, and we can put in the rand function, and the rand function finishes with an open bracket and a closed bracket, like so. In fact, those are not the right brackets, they need to be round brackets, and those are curly ones. So it's those ones just there. And so rand, if we just execute on that, you'll see you do get a random number in here. If you try the same thing again, it's different. So the rand function would do the trick and get us the mark. There's various other ones that would as well, but that one mark could be got by using the rand function.